Okay, I think we can just start. Right, so I put out this meme here. Do you understand what this meme is talking about? You know? Like, oh, okay. Yeah, so if you learn calculus, right, you know there's a formula saying that d over dx s squared equals to 27. Sorry, 27 to x. So this is what happened if you just teach formula, if you just learn by example. Correct or not? Correct, man. If I'm a student, I also can replace x with 7. Correct or not? But what is differentiation mean? You need to differentiate a function, okay, with respect to some variable. Or later we will see this variable actually means direction. Okay, in one-dimensional, there's only one direction. But in three-dimensional or n-dimensional, we have more direction. Okay. Okay, so we're differentiating with respect to directions. If Okay, let's go to the next stage. If in one day you found a direction in 7, maybe you can differentiate with respect to 7. Who knows? Okay. But for now, these are just constant numbers. Okay. So there's nothing to differentiate with respect to. You can treat this as a function, constant function, but what is this variable here? Is 7 a variable? Not right. 7 is not a variable. Okay. Yeah. Okay. Another thing. So let's give some context to what we have learned. Okay, so let me give you some context. Maybe you can do further study in your project. So, actually, how mathematics advanced until today. So first, the Greek or the Babylonian, right? So what they do is they will do geometry. Okay, what sort of geometry? Those things you learn in your high school. For example, triangle, what's the angle, what's the total angle of the internal triangle, and then circle, and so on. They do it without coordinate actually. On the other hand, we have these Indian or Arabian. Okay, Arabian. So actually, Arabian maths is quite advanced at once, right? Because for now, what number ring you are using actually? You are using Arabic number. You know what is Arabic number? One, two, three, four. You're writing Arabic number. Do you write 1, 2, 3 or no? All right. Okay. So um, there's one time these Max is very advanced in Arabic. What they do mostly is about algebra. Okay. So like what we studied before, x squared plus y squared equals to 1. Then there's one guy in French, okay, called René Descartes. Okay, René Descartes. So there's a S there, but it's a silent S because this guy is a French guy. Okay, René Descartes. So this guy married these two ideas. Okay, which they call analytic geometry here. Now maybe you wonder why is it not called algebraic geometry here? Because they still they introduce this algebraic uh, tools to geometry to study local property. Okay, algebraic geometry study other kind of property. So what does René Descartes do? He put the, for example, unique circle on R2, which is what you learn today. Okay, which is what you learn today. So we put uh, Cartesian coordinate on, or rather we put geometry on Cartesian coordinate. So that's why it's Cartesian. Cartesian is to honor this type. And we Cartesian. Okay. So this guy is also a very famous philosopher. There's one very famous phrase said by him. He said, "Who are you? Who are you? You know who are you? How you define yourself? Why you exist? For example, why I'm sleeping? Why?" Then he said a famous sentence. He said, "I think, therefore I am." Because you think. Imagine how what if you stop thinking one day? I don't know who are you. Maybe you don't even know who are you. So don't stop thinking. Okay? Don't stop thinking. Right. Another thing is about dy dx. I guess about two description of dy dx here. I've shown you. Actually, where? Okay. Let me see. Should I talk about it now? Wait, let me check. Okay, maybe we talk about dy dx later. Okay, never mind. Right. All right. Um, any other like comment or question from your last lecture or from your tutorial exercise if you try out any question? Or there's some concept that you don't understand? Make sure you learn by concept, right? So if you go back and do exercise and then you find out, hey, I don't know how to do, go back and check the definition again, check the theorem again. Which part you don't understand, and then you should ask. Okay, ask from there. Ask from the theorem or concept that you don't know. Then we can explain in example again. But don't just learn by example. Okay, don't just learn by example. I give you a very, I mean, very practical thing to think about. For example, if you ever went to a Simon Moraes competition, or even you see any maths competition, Olympiad or whatever, kangaroo or something like that, you think hard or you think hard, you think it is hard. But the point is, if you look at the solution, those are the things that you learned before. So this is about understanding now. And this is what you can learn in the maths degree. You need to understand, learn to understand. Understand what people write, understand what people say. Okay, not just follow what people ask you to do. Yeah. It's very important. Okay, so this will differentiate uh, whether, yeah, differentiate people. Okay, so make sure if you don't understand anything, you have to go back to the concept and then ask from there. Okay, if there's no question, we will continue with new material today. So next thing we'll compute is about the area under the plane curve. Yeah, area A under the plane curve. Area under the plane curve. Suppose our GT is greater or equal to 0. Okay, so let's spend a moment think about this formula first, and then I'll tell you where it came from. Okay. Think about this formula for a while. Okay, so like what I asked you to do, right? You should be able to draw. Okay, I think almost everything in this course you can draw it. You can draw it. Okay, almost everything in this course you can draw it. So there's a special condition there you need to take note. You see that GT is greater or equal to 0. Meaning what? Where does this y coordinate lies? Above x-axis. Okay, it lies above x-axis here. So let's draw something like that. Okay, let's draw something like that above x-axis. And let's say this, we start at the time A and then to time B, right? Okay. So if we want to get this area under the curve, you know how to get it or not? Oh, do I know the function of y or not? I know, right? So this function of y is gt. Okay. So if you learn in the calculus one, right? What do you need to get to compute the area under this curve? Sorry? Mass and height, sure. Okay, so you need to first get the endpoint first, right? Okay, so what's the endpoint here? What's the two endpoint here? F, FAN, F, FB. Okay, so potentially you can write something like this. Integrate from FA to FB of y dx. Okay. But if I write this way, this means what? The y there should be in terms of x. But instead of y in terms of x, what do we have? We have y in terms of t. So how to change the variable x to t? I think you also learned in this one, right? What do you do? Integration by substitution. Good. So what do we substitute here? We substitute x equals to f t. And then what is dx here? Dx is f prime t dt. Okay, so you do integration by substitution. So you get from a to b of gt of f prime t. So we do integration by substitution. Okay, yeah. Okay, so if you want to calculate, make sure one of them you remember to differentiate. Which one is the x one? Because you do the integration by. Okay, clear? Easy to follow. Okay, so let's try one example. Okay, let's try one easy example. Yeah. So let's take the semicircle. Let's take the upper half semicircle here. Okay, let's take this one. So this is a semicircle. So whenever we talk about circle, two things is important. What are the two things? One is the origin, the other is the, oh sorry, one is the center, the other is the radius. Okay, so this semicircle is centered at the origin with radius 1. Okay, r equals to 1. So in this case, if I'm gonna ask you what's this area bounded by this curve, what's this area here? Hmm? The formula of area of a circle. Hmm? What's the area here? I over 2, right? Because half pi r square, right? R here is 1. So you have pi over 2. So try and use our method just now and see do we get pi over 2 or not. Okay, let's try and work it out. Take out your pen or your iPad. So how do we parameterize this? Test you a bit. How to parameterize this curve? I think so. S equals to what? Y equals to what? What's the equation that satisfied by a circle? What? Say the answer. What did you say? What's S2 plus Y2? Uh-huh. Equals to 1. Okay, how about right now the parametric equation? How to describe using extra variable here? The hint is trigger. Uh-huh. Cos T and sine T. Cannot forget this one. You must know cos T and sine T. This is a basic parametric curve. So where do we take T from? T from where to where? In this case here. 2 pi? Pi only, right? We only take half of it. Okay, so 0 to pi. Okay, so everyone try and compute this integral now. So 0 to pi of what? gt f prime t dt. Okay, I give you 2 minutes time compute. Try do this integral. Okay, seems like some of you got it already. So if you integrate further, you should get negative t over 2 plus 1 over 2 times 2 sine 2t. Integrate from 0 to pi. What do you get? Pumping, what do you get? Minus pi over 2, eh? How come? Minus pi over 2, eh? Okay, the answer is not wrong. But why is there a minus sign here? Okay, as a mathematician, if you check already, the calculation is not wrong. Okay, then maybe this minus sign is suggesting some other structure inside the geometry. Okay, so it might be suggesting some structure here. So if you look at the definitions we had here, where's my t? My t go from where to where? From A to B. Okay. So last time I say that if you look at your time, right, you can draw an orientation on the line. So orientation on the line means what? You can only go two ways. Either you go left or go right. Okay, in this case here, you go from left to right. But on the other case, where's this time going from? T0 to T pi. So you're actually going from the right to left. Okay. So meaning here, this definition of integral actually depend on the orientation of your yeah. Okay, actually depend on the orientation of your curve. Okay, so I'll remark here that for warning here, integral depends on orientation. Okay, so actually I never taught you about orient your curve in the other direction. Okay, we only define orientation in one direction. But if you look at which book, I think Adam. Okay, if I'm not wrong, it's Adam. So you can check out Adam that they have like four orientation to look at because you need to consider sometimes your G can be under the x-axis also. Okay, so you have four cases to consider. Actually, this is a good topic if you want to do in your project. Okay, how different orientation give you a different sign of input. Does it make sense? Okay, yeah. So I think this is a very good topic. So next time, be careful when you integrate, you get some sign. See if you get the right orientation of your curve. Okay. So actually in high school, when you do Riemann integral or what, you only really care about one direction. Okay, you really only care about one direction. But since we are parameterized curve, right, we can swap our time direction. So need to be careful a bit. Does it make sense? Okay. Do you know how to swap this direction or not? Is there any way to swap this direction? Do you think? Can you change the domain such that the direction of curve is going from the left to right? Can you think of a way to do it? From what to what? Let's try. 3 pi to 4 pi. Like this? 3 pi, where's 3 pi? 0, 0, pi, pi. Let's count again. So 0, pi, 2 pi, 3 pi, 4 pi. So you are drawing this way. But what I meant is you kept your y function up, but you just swap your orientation. Can you do it or not? I think you cannot use positive anymore because positive, the direction is like this one. It's always anti-clockwise. But what I want you to do to make it clockwise. So how do you make it clockwise such that you keep the upper half circle? Think about it. Clockwise 的angle 应该怎么 label 啊？有人会吗？怎么往另外一个方向跑？ Yeah, use minus. 0, negative pi over 2, negative pi, and then, so it should be negative pi to negative 2 pi. Try yourself. Go integrate again. You get pi over 2 or not? See if you get pi over 2 or not this time. You get pi over 2? Should we compute together? Let's compute together. If we get pi over 2, I wanted to compute quickly, but we cannot. Never mind. You get 2 pi? Sine 4 pi is 0, right? Sine 4 pi is 0. And then 2 pi is still 0. So minus. Yeah, you get pi over 2. Correct? Did you guys calculating? You convince yourself or not? Have you convenient answer? Wait, I just change the integration domain here. And then try and compute this. So this term always disappear, right? No matter you put 2 pi or pi, because it's a multiple of 2 pi. Correct? Sine 4 pi, sine 2 pi is 0, right? So what's left is this term. So this term, you substitute negative 2 pi, what do you get? Pi, right? Okay. If you substitute negative pi, you get pi over 2. But you need to minus, right? So you get pi over 2. Okay, does it make sense? Okay, so this means that the orientation is very important. What I defined for you, only one kind of orientation just now. Actually, we should define all kind actually. So on the top, we can go left and right. On the bottom, we also can go left and right. Okay, so the full definition you can find in Adam. Okay, it's good to write it down if you want. You can do it in your project also. Okay, so far any question? Question? No. Doing this clockwise, the anti-clockwise thing, later will come very important when we learn polar coordinate. Okay, so try and get used to it. Right. 哎，我是玉良，10点，怎么9点有 appointment？去，OK，请不来要请我们全部吃东西。这样，我们在讲解决这样的问题。OK，sure. Okay, so continue. Right, so we have a surface area. So what's surface area here? So imagine you have a XY plane. Imagine you have a XY plane. And then you can take a piece of curve and then you evolve around this x-axis. Okay, I think you know this construction before, right? So you evolve around this x-axis. Okay, so you evolve around this x-axis. What do? You actually pace out a cylinder. Right or not? Pace out this cylinder here. So can you compute the surface area of this cylinder or not? Just using this piece of curve here. Do you know? Hey, first of all, do you know? Can you see this is a cylinder or not? Can? Okay. Right. So cylinder in this way. So what's the surface area here? Can you compute? Just using this piece of information. Can you compute or not? Let's say we know how tall is this y. And then let's say what? We know how long is here. Let's say r. Is it r? Maybe not put, don't put r, confuse you later. Let's put s maybe. How to compute? This is a straight horizontal line, no? So it's a regular cylinder here. How to compute the surface area? Any idea? Two pi y times x. Where do you get this? 拆了打开，拆了打开。I mean, in the other way, another way to see this is this cylinder here. How do you think about cylinder actually? What do you think about cylinder? Actually, built out by a bunch of circles. Okay, built out by a bunch of circles. Okay, so you really combine all the circles together. Okay, all the circles together. Does it make sense? Okay, so you have 2 pi radius time x. Okay, so you as many 2 pi 2 pi 1. Okay, but life is not so easy. Life is not so easy because maybe your plane curve is not straight. Your plane curve is not straight. Okay, but you still can evolve around the x-axis. Okay, but this time what? What do you get? You still get a cylinder here? Yeah, you still get a cylinder. Okay. So what to do here? So what's the general formula for a curve that's not straight? Oh, to say that the area of the surface obtained by revolving the parametric curve. Okay, so we always deal with parametric curves now. X equals to ft, and y equals to gt, or t in between a and b about x-axis. Okay, it's very important. This is about x-axis. So you can imagine you can also do it around y-axis, for example. Okay, it's what? Is x equals to, let's say, integrate from where to where? Let's see. From where to where? So let's put it from a prime to b prime first. So what's this a prime, b prime here? It's about yt. Sorry, it's about dx. Okay, so dx here refer to this length of this curve here. But we can make everything in terms of t now. Okay, so you can see that quite weird. We have what? We have the height. Okay, height is in terms of t, correct or not? If your length changing, your height will change with respect to time also. Okay, sometimes high, sometimes low. Okay, but how to compute this dx here, like what we did last time? We have to use a lot of fixed ruler to approximate it. Okay, so we need integral here. But you can see that, hey, you differentiate with respect to time. Sorry, there's time variable here, there's a length variable here. Can we make them consistent or not? Okay, so we can make them consistent because we know the formula for dx last time. Okay, so last time I show you that we can compute the length of the curve using Pythagoras theorem, right or not? So you can use this Pythagoras theorem here. So meaning what? I need dx, dy. So meaning this curve actually has to be differentiable actually. And so we actually require this curve to be differentiable. So we might add differentiability here. Okay, then in this case here, we can change all the variable to time. So this is why I put a prime and b prime first. Okay, so now we will change all the variable into t. Okay, so the last expression here makes sense. Okay, why it makes sense? Because every function is in terms of t. And you can do that. Any question? Okay, if no question, let's do one example also. Let's try one example. So once you think that you understand, you should try example. And then as example don't understand, go back to read. You think that you understand, do example. Until you know how to do a proper example using the, then you can stop. And then you go to the new concept. Okay, so this is the workflow you need to do in mathematics. And not just example. Read the theorem or definition, do one example. Start, go back and read definition again. Okay, you think okay, then move. Example. Okay, so keep going back, forth, back, forth, back, forth. Until one day, I told my FYP student, until one day, which day? Until the day, once you read definition of theorem, you can write down your own example. This is the day that you will understand what people say. Almost everything. 就是说你能够已经有能力想象别人你要表达的东西，明白？You need to reach that day。因为我已经到了，所以我跟你讲有这个东西。如果我没有到，我讲不了这个东西。有讲过吗？这个东西，就是当人家在跟你讲一件事情的时候，你从来没有想象过，但是他一讲出来过后，你就会想象他在讲什么。这是一种能力来的，有人天生有，但是我还跟你讲，这个能力是可以学的。All right, so let's try example. Try this example here. So let's start with drawing, then we can describe it. So the drawing is the same. Again, it's the same. But maybe we do it more in a more generality here. So let's take this semicircle again. Semicircle is our good friend, or the circle is our good friend. So we should always remember him. So let's take this semicircle again. If I do this circle evolution around x-axis, what do you think you will get? 一个完整的 semicircle 绕着 x-axis 转。What do you get? Sorry? A ball. Sure, a ball or not quite a ball, it's a sphere. Okay, it's a sphere. Ball usually we will fill in the space, but sphere we don't fill in the space. Okay, so this is the difference. Okay, so we'll get a sphere. So, what? 哦，波是空心哈，在数学里面usually ball 是里面有东西，usually，yeah，有时候我们会叫open ball，哦，有，对啊，就是有东西，ball 通常在数学里面是有东西。现实中也应该也要有东西，没有东西的话，那个球会垮掉。你要搬气，you need to pump in the gas into the balloon, for example, to keep it in shape. So actually 是有东西，但是那个东西不是 solid maybe, but still have 东西。没有东西，那个东西一定是垮掉了，哪里去？Okay, but anyway, so we get a sphere. So what's the surface area of a sphere? You learn. 啊，背过吗？Surface area of a sphere. 4 pi r square. Good. 4 pi r square. So let's see if we can get 4 pi r square using our seemingly complicated formula here. Okay, so let's set out the integral first, and then I'll let you try to compute. Again, parameterize this curve again. So this C is what? X equals to R cos T and Y equals to R sine T. Okay, going from where to where? From 0 to pi again. Okay, so try and find the surface area. The surface area of the sphere of radius R obtained by rotating the semicircle C around x-axis. Okay. So what's the formula? So the formula is integrate from a to b of 2 pi yt, and then you need to differentiate your x variable with respect to t, square it, plus differentiating y variable with respect to t and then square it dt. Okay, so if you put everything together, what do you get? So try and compute, see if you get the same answer. Okay, finish computation. Do you get 2 pi r squared times minus cos t integrate from 0 to pi? No. You get this? Compute, I give you time. Try and do some integration. Okay. Okay. Okay, everyone got it? See if any calculation wrong. Please check. Okay, everyone happy with 4 pi r squared? Okay. Another thing I want to comment before we take a break now. So, where's our angle just now? So angle example. Oh, here, yeah. Okay. So maybe some of you, any one of you think why when 0 to 2 pi we are doing 0 to 2 pi we are doing anti-clockwise, but when we do negative 0 to negative pi and then negative 2 pi we are doing clockwise. Anyone have this question or not? No question? No. Because I know some of you will have this kind of question. Sorry. Someone design. 喂，你那个是另外一个问题。等一下先。So I mean, why negative mean the other direction? Do you know? So for example, in a real line, you know that after 0, you will go to the right? But negative, you go the other side. So -1, -2, -3, -4, like that. Okay, so similar here. You just wrap your real line around this angle here. So how do you wrap it around? So let me draw something like this. So here is some positive theta. Okay, you see this as a 0 angle here. Okay, and then if you move away from the right, move away from the above. Okay, so we see as positive. But if you move the other direction, we see as a negative. Okay, so you can think of a real line wrapped around this circle here. Okay, does it make sense or not? Okay, but there's some very nice thing about this angle here. Even though real line is different, you see. If you stay at a positive, you had never go back to negative one. You can never do that. You can only always stay negative or stay positive. But angle is different. No? If you go positive long enough, you can reach where your negative theta can reach. Okay. So this means what? This means that if you get a point on this circle, there's two ways to get to this point. One way, I mean two ways to get to this point from the zero angle. You can either go anti-clockwise or you either go clockwise. Does it make sense? They still represent the same point on XY plane. Okay, there are two ways. But if you look at the real line, right? If you want to go from zero to anything left or right, there's really only one way on. There's really only one way. Okay, so this is a nice thing about circle. Okay, you can go left, go right. It's fine. Later we will make full use of this circle thing, which is the polar coordinate. Next hour. Okay, what's the other question now? I did ask. What do you have next time? Oh, sure, sure, sure. Okay, 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 okay. So you mean, let's say I want to compute the area under this curve. Why this direction is positive, not this direction is positive? Something like that. I would say this is the. I wouldn't say this is a defect, but this is a consequence of how we define integral. This is the consequence of how we define the integral. Okay. Somehow this orientation of this curve will affect what you computed. Again, I mean, we mathematicians, when we make formula, we will see there's a lot of possibility. So let's say you go from left to right, okay, you get positive. From right to left, you get negative. So which number you want to take? You want to take positive one or negative one? Which one? Then you need to ask yourself, what I want to compute now? What I want to get now is an area. Then you ask yourself, if I want to bound an area, should my area be negative or positive? So we choose the convention, we choose this convention to define this as our area. Maybe in some day, negative area got other meaning. Then we take negative area. That's all. So that's why I say definition is very important one. For us, we just make definition to suit our need. That's all. What you want. In this case, I want area. So if I really bound an area, my area should be positive. But somehow, if you fix this convention, then if you change the orientation, then the negative will pop up. But you need to remind yourself, this negative is because orientation only, or what, something like that. Yeah, so I mean, this number has meaning, so you need to dig the meaning out. Okay. Maybe next time there's some better way to define this area. Don't need to depend on orientation. Who knows? Then your son will learn that way already. No need this integration. Yeah. It's like that one. Knowledge is like that. No use one, we throw away. But now it's useful, learn first. This is how knowledge advances. Okay. Any other question? Any other question? Sorry, yeah. Where is horizontal line? Oh, yeah. What is the area? But horizontal line curve. You mean oh, okay. I think I get what you mean. You mean something like this, huh? I mean something like this. Yeah, you are quite right. But somehow it works. You can try and prove it. The detail is in Adam. I think Stewart also mentioned this. I'm not sure, but Adam should have. Hmm. Because if you think if you come back your time also come back. So there will be some cancellation happening. I just give you an idea, but you should go and check it out. You understand what I said or not? No, okay, repeat again. You listen carefully what I say. You don't need to understand, but you go back and verify my word. So if you have like curve like this, okay, and then you still want to figure out what's the area under this curve, okay, so you use this formula, right? You use this formula, but not that your time go from here to here, but it comes back. So the orientation change. So if you sum all these together, it will be some cancellation. And somehow this cancellation will give you the right answer you want. You know what I'm talking about now? So going back and verify it. It's in Adam, if I'm not sure, if I'm not wrong. I think Adam got. Stewart, not sure. Adam got. Yeah, I think this is a good project to write it out. Good project, this one. Yeah, very good project. Yeah, about left and right orientation, and then left and right at the bottom, and then like what Jian Tong say, if the plane curve go around it, do you still compute the right thing or not under area under? Yeah, very good. Okay, it turns out yes. Okay, so you go back. By the way, I skipped all the cycloid example because I don't want to do tedious calculation here. So maybe you can try it yourself. I provide solution in my lecture now. Any questions so far? No more. Maybe we take a break until 10:06.我来这，放掉啊，放掉。哦，OK，放掉，放掉。哦，对啊，放掉了。我想一下怎么办。对，放掉。有办法，再加一个减。我就觉得我少了一个减在哪里，我一直想不到。我这个主角，我觉得这个版本，我觉得应该是用减 T 吧。啊，没有是 T 加个符号，S 可以加个符号。哦，S 加符号也行哦。对吧？哎，都是 T 加个符号啊。如果是 T 加个符号，大家可以在这符号应该 T 加个符号比较好。是不是？加个符号比较好。啊，是是是，但是我要达到那个效果，我觉得好像不可以那样写，其实。所以 T 如果放一个负号过后，我就可以 T 就重拍到2拍。是你要接反的箭头。可是箭头倒反的话，我们还是要从减2拍到减拍，然后我们又要自己乘一个减，就很假。这样认识。我知道，我知道，我知道。 但是你那个转方向下面又要转了，后面转的话又算是减出来了。从小的一个 grade 去大的，就是它的已经 point 就是从 F 排开始吧，然后到 N point 是 photo 排，为什么？我就可以达到从这边到这边，指定我每个快跟 N point 的位置不一样。但是我觉得我们开始的地方到时间结束了，这是不可以的。但是你是从结束到开始，所以我是说能不能换其他东西 such that 这个比较 make sense。一个东西就是换 t 哦，还有一个方法就是减 t 啊，啊，变成 x equal to sin t y equal to cos t。x y 转有用，我就是直接把 n 给转一个方向，然后再把它的那个 x y 转的话，应该是直接就这样子转，应该是变去，应该是那个科会跑去 right 的乘以这个，欸我放一个减在 t，放 cos t 那边，这样，然后上面就是拍到二排，对，这样哦。如果 cos 如果 x equal to negative 一哦，然后我的 prime 从还是拍到二，连就可以达到这个减拍到减二拍效果。x y 还在，那个是 x 反过来，懂了吧？这算是哦，对啊，懂。是把那个轴为了达到这个效果，我就可惜的这样子，然后我的 t 就从还是拍到二拍。你那个，我是说你会变成这个东西，你会变成这个，你 x 跟 y 交换了吗？对不对？你跟 x 跟 y 交换，你应该是 reflect on x 等于 y 这条线啊，所以没变。我想一下啊，为什么要改 y？y 是这条嘛？y 是在上面啊，不可能改 y 吧？
你从如果你从那个拍到二拍的话，如果是这个公式，
嗯，
它会是往下面
对。
y 乘个负号，这不就反过来就这么想？
哎，等一下我想一下。
对
哦
对
哦，因为我已经换了这个东西，其实，哦，我已经换了这个东西啊，这样两个都放副题哦，你的意思是说？
对，
因为我都换了这个 domain。啊，对对对，make sense，make sense 嘛？哎，等一下先我想一下。啊，等一下，等一下，我想一下它这个东西。哎，对了，这个对了，这个才比较对。OK，这个对啊？什么？你解释？因为 x 可以 equal to cos t cos square t 嘛，啊，所以我可以有这里也可以有负嘛，所以我可以出使用负 cos t 和 x equal to，你说 x equal to 负 cos t 是不是？呀， 用 full plus t，你说用同一个 domain 是吗？
同个 domain 可以。
哦，对，呀对，OK，也非常好。哎，等一下讨论一下。10点了，一年还没有来。OK，冰箱。嗯，啊？没有没有吗？没有 answer。Okay, how about let's start first. Okay, so Isaac pointed out this interval just now we use one a bit weird. So if we have an order from negative pi to negative 2 pi is good, but this is not the case, right? Because we know that negative 2 pi is smaller than negative pi. Okay, but how to solve this problem? So just now we have at least two ways to solve it. Okay, one way is we keep this pi to 2 pi interval. Okay, and then we introduce a minus t to them. What does this mean? So imagine what? So imagine you have pi. So if you imagine you have pi to 2 pi of cos t and then sin t, what's the original curve here? It should be the lower semicircle. Okay. But if you introduce a negative to the x and y variable, this lower semicircle here will get reflect out. Okay. So this is one way to solve it. Actually, the other way to solve it is easier. So let's get rid of this. The other way to solve it is since you already know that from 0 to 2 pi, we are going anti-clockwise. What else we just need to do? We just need to flip the x variable. So meaning we put a negative in front. It will flip the x variable. So there's at least two way to draw this semicircle with an orientation clockwise. Okay, at least two ways. And you should compute that these two ways should give you pi over 2 actually. Then go back and compute. Convince yourself. Okay. Either you convince yourself, either you found my mistake. That's all. There's two possibilities only. Okay, so try and compute. See if you get pi over 2 or not in these two cases. Okay, so one thing I want to demonstrate to you is for parametric curve, you can use your creativity one. Then you can change your formula or change your domain. And then you can get the actually same curve. And then it turns out that these calculation doesn't depend on your parameter. It doesn't depend on how you parameterize your curve. So this is a nice thing about this theory. It doesn't depend on your parameterizing. Okay, if it depends, then there's no point to do this parametric curve. Okay, so it turns out that this value doesn't change. Okay, on how you parameterize your curve. Okay, any questions? I mean, there's even more things you can do with this parametric curve here. You can like speed up the curve, speed up the time, okay, or make the time slower. But if you want to achieve the same curve, then you need to change your domain. Yeah, and you can try to speed out your curve or make your curve slow by changing your parameter. Okay. Yeah, try and go and experience it. Try and experience it. Okay, let me write it for you in case you don't know what I say. So how about we put 2D here? Okay, then maybe my time will go from t to 1 over half. Okay, you can see that. Why I said this is speeding up, because to go around the same semicircle, you only need pi over 2 time only. Okay, so you speed up. And you use less time to travel. Okay, but previously you need whole pi to travel, but now you need half pi. So now I speed up. Similarly, you can slow down. Slow down means what? You need longer time to travel. Okay, for example, you put half t here. Half t here, then you need how many time to travel to achieve the same curve? You need, for example, 2 pi. Right? Pi times half pi is pi. So that you add the same. Okay, so you can play around with this parameter. Right. So let's continue. Okay, so we'll go into polar coordinate now. So things about polar coordinate is the things that never change in polar coordinate is always we live on a xy plane. Okay, we live on the xy plane here. Remember, we still live on the xy plane. So one thing you know very well is Cartesian coordinate. Or sometimes people will call it xy coordinate. Or people sometimes call it regular, okay, rectangular coordinate. Okay, rectangular coordinate. Okay, so in a moment you'll see why is it rectangular. Well, let's start with the usual xy plane here. Okay, so how to describe a point on the xy plane? You will use two coordinate, which is x and y. Okay? And on this xy plane, right, you have a lot of dot. You have a lot of dot. And all these dots are made up by x and y coordinate here. Let's name this x1, y1, so not to confuse with the variable. On the other side, we will learn what's called the polar coordinate, okay? Or sometimes we call it the r theta coordinate here. Okay, so how we imagine this polar coordinate here? Okay, how do we imagine it? So how you imagine was you want to use a bunch of circle to represent your point. Okay, why you can use a bunch of circle representing your point? So instead of thinking your point like this rectangle style, x and y, right? X1, for example, and then y1. What you can think is any point on this xy plane, it should live on a circle that is centered at the origin. Just that you have a different radius, okay, with a different radius. But how do you make sure on which part the circle live in? You can use the angle, okay, angle from the x-axis, for example. Okay, so how you imagine was you imagine that you slice your xy plane into bunch of concentric circle, okay, centered at the origin. 明白吗？明白吗？ And this is how radar works, right? Radar. So the radar send out the signal in a circular sense, and then you can test where the ship located. So it really cover the R2 plane. It really cover the R2 plane. 能吗？可以相信吗？每一个这个如果放无限个圆圈来做 infinite circle here with infinite radius, with radius going to infinity, you can cover the whole R2. Yeah. So did you notice one thing? On one side we have two variables, the other side we also have two variables. Do you notice? We cannot use less than two variables to do this. Do you know why? Yes, good. Exactly. You learn in linear algebra. X and Y variable are linearly independent. If you want to use another way to describe it, you still need two-dimensional basis. You still need. Okay, so in this case here, we make it into radius and angle. Okay, instead of X and Y. Right. So let's do some concrete maths here. Let's do some concrete maths here. So let's say I give you a point xy. Do you know how to convert to r theta or not? So meaning I ask you, if I gave you a point on coordinate, Cartesian coordinate, you know which circle it lives on? If I tell you which circle it lives on, you know what xy coordinate it has. Okay, so we need to figure out this formula here. You know how to figure it out? Let's do one direction first. Which direction? Let's say we know which circle it lives on. Okay, I know radius already. I know theta already. Can you give me the xy coordinate? So let me draw on this picture here. So let's say we want to figure out what's the xy coordinate of this point. Okay, so what's the s coordinate? What's the y coordinate here? How to compute? Y equals to what? X equals to what? If I know about the angle here and the radius here. So how about let us remove some of the circle. Yeah. Okay, we know the radius. We know the theta already. Can you get x and y? How? Check you. 不是玉凤，OK，玉凤，sorry 啊，check you，我知道，我只是搞乱你们两个，OK，玉凤来，how to get x y？r cosine theta and then y equals to r sine theta. Good. Okay. So this is the circle we have been building, right? How about the other direction? How about the other direction? How to get r theta if we know about x and y? Not too hard, but a bit tricky. How? What is r? What is theta in terms of x, y? Isaac. Square root of x squared plus y squared, and then tangent inverse x over
Y over X.
y over x or x over y?
Y over X.
Y over x? Let's check it out. So how to get this? How to get something on r? We use the same formula here. We use the same formula here. Why? Because we rely on the fact that the circle that we consider is always centered at 0. So there's no shifting on this circle equation here. Okay. So what? So we know what? We know that these xy are, so let me write down the logic here. So we know that the point xy must lie on a circle with radius r for some r centered at the origin. Okay. Meaning r cos square theta squared plus r sine theta squared have to satisfy the equation equals to r squared. Okay. So if we want to know r about xy, what do we need to know? We know that x squared plus y squared has to be r squared. And then in this case here, there's two possibility, right? Plus minus x squared plus y squared. But at the moment, we will just consider r to be positive first. Later, I'll tell you what happens if it is negative. Okay, so choose the positive one. How about the angle? How about the angle? How about angle? How to figure out the angle? Is that how you come out with this tangent inverse? Is what? Okay, so let's write down what's tangent mean. So you mean consider tangent of what? Theta equals to what? 1 over x. So how do we get this 1 over x thingy? So you really need to come back here and then look for the angle. Okay, that this point made with your axis here. Okay, so this angle is always taken from the positive. Okay, to be precise, is the positive x-axis. Okay. We take the positive x-axis as the 0 angle, and then you go to the above, which is the first quadrant, pi over 2, and then pi, and then 3 pi over 2, something like that. And then you go around again, 2 pi, and then you continue. Right, so you get from theta here is tangent theta equals to y over x. So this implies that theta is equals to tangent inverse of okay. Yeah. Any question so far? Any questions? Yes. 这里的 x 是什么？可不可以是零？可不可以是零？可以，可以是零。你说这边会有问题？Yes. So I mean, we need to define separately in that case. Now we need to define all the point on x equals 0 differently in that case. In that case, what happens if my x is 0? So if my x is 0, okay, if my x is 0, you can immediately see that it is either pi over 2, or if you go downward, should be 3 pi over 2. Yeah. So this formula might not work when x is 0, but you still can see it from the x. Okay. Yeah. So that's why sometimes I also very reluctant to teach formula, because not all formula is universal. I mean, work for all cases. But this concept work for all cases. If I teach you how to draw this, and then you can go and find what is the angle. Because really, in some cases, we need to define separately. We need to define separately. Because this really cannot compute 0 for us. I mean, infinity. Hey, imagine what happened you do inverse on infinity. Because if you go very far, there's different image you can reach. It keeps changing one. Remember your curve, sometimes go up, sometimes go down, sometimes go up, sometimes go down. So which one you refer to? Don't know. Ambiguous. Okay, so we cannot do tangent inverse infinity. Okay. Right. So this is about polar plane. Okay, so let's look at polar coordinate closer. So let's do it one more. Let's define some terminology here. So what really need by polar coordinate is what we call a polar axis here. Okay, so the most important thing is the positive x-axis here. And then this positive x-axis will swipe out all the point. 可以想象我在讲什么？ If you take a different radius of length of positive x-axis, it can swipe out a region, a circular region. Okay, hello. 早安。早安。哎，我跟你讲早安，你没有回我早安呢。啊。Okay. So you have a radius length R. If you do this circular motion here, you will swipe out a region of circle. So imagine you take longer radius, you will swipe out even larger circle. And in this case, you take larger and larger radius. You can imagine that you can cover the whole plane. I mean 不能就有点危险。Yeah. Huh? Yeah. So if you take this polar axis here, and then you rotate around the origin, you swipe out a circle region. Okay, so xy coordinate has two axes, x-axis and y-axis. But polar coordinate we also have two axes, but not quite an axis. We have one polar axis and one point here we call pole. 知道什么是 pole 吗？它不是旗啊，旗杆，杆啊，那个杆。旗？哦，是咩？哦，确实哦。我觉得是杆比较，你的杆，我觉得是杆比较适合。杆会比较适合，因为 because we really swipe this polar axis around this， 明白吗 ？OK， 你想象那个 pole 嘛，有旗嘛，如果你风吹那个旗子，是不是会绕那个 pole 一圈 ？Yeah, this is what you need to imagine here. Okay, so that we can get all the points within the radius. Right. Okay, so just now I tell you that, I mean, in your mind, right, you should think of radius to be positive, but we can define negative radius also. Okay, we can define negative radius also. So what does it mean by negative radius? So it's the same as the real number line, real number line. Okay, so if you, on one side, you can keep going positive, but you can also do negative r. Okay, we can do negative r like this. So this negative r should be less than 0. So, yeah. So what's the angle here? What am I doing here? Actually, I add another pi. Then this point here is called negative r. Okay. But you should not notice that this point has another name, right? Using the first formulation. If my radius has to be r, what's my theta then? This theta will become theta plus. I think I should draw this like this better. Draw all the way from 0. Okay, so there are at least two ways to describe a single point. Actually, there are more. There are two more ways. Let me see. Let's give you an example. So let's do example. Let's see the example inside your note. Okay, so how about this one? So let's fix the usual one. So let's talk about this point here. So let's call it 1 and 5 pi over 4. Okay. So there are a few ways to describe this point. So just now I told you one way is you can imagine that this point here is get reflected by the other point on the same straight line pass through the origin. So for example, how can you imagine this point here? If you imagine it as a opposite of the point on the same straight line, what's this angle we should get here? This angle should be 5 pi over 4 minus pi, which is pi over 4. Okay, with the same radius here. So if you take negative, we will get negative 1 of pi over. Okay. Hey, not there, be careful when you compute, don't confuse. If you change radius, then you might change your angle also. But if you compute from that point, you shouldn't change your angle because the radius already helped you to predict. Okay. So don't confuse that. Think again, what are you trying to do? What else? Like what I said just now, right? You not only can consider anti-clockwise, you can consider clockwise too. Okay, so if you consider clockwise, what's the angle here? You know how to compute it? Okay, how to compute this direction? So what's left? So these two angles end up to get 2 pi. So What's the angle left here? I think so. 5 pi over 4. So what do you get? It's 3 over 4 pi. 3 pi over 4? 3 pi over 4. 3 pi over 4. Okay. But plus or minus? Negative, right? Because you go the other direction. So it should be negative 3 pi over 4. So you can name this point as 1, comma 3 pi over 4. Okay. And there's actually another hack about this point here. So what can you do? Actually, you can add a multiple of 2 pi. You still get back to the same point. You can add multiple of 2 pi. Okay, so let me put it here. So 1, comma 5 pi over 4 plus multiple of 2 pi. Let's say like this. Okay, for m in m. Okay, multiple of 2 pi. So multiple of 2 pi also apply to the other cases. So actually, there are infinitely many ways to write one in the polar coordinate. Okay. Okay. Any question? Okay, I suggest you try and go back and try all these points. Right. So maybe you ask, what's the usefulness of this polar coordinate thing? So what we're gonna define is called a polar curve. Okay, this is much better than our function in xy. I'll tell you why this is much better using example. So what are these polar curves? These are the function in terms of r theta. So you can write r in terms of angle. So for example, let me give you an example. So can you imagine what does it mean by radius equals to 2? Or what does it mean by theta equals to 1? I let you think 1 minute first. I want to tell you. Think about these two functions. How to sketch it. What does it mean by radius is 1? And then what does it mean by angle is 1? How should you draw on an xy plane? At what point satisfy radius equals to 2? What point satisfy angle equals to 1? Okay, any idea? What point satisfy radius equals to 2? Circle. Circle. What kind of circle? I equals to 2 at center at the origin. Okay, so center at the origin with radius 2. Theta equals to 1. All the point that make up angle with 1 radian here with the positive axis. So what can you see here? Wow, last time we have trouble writing circle using a function, right? We cannot write y equals to some x. We need at least 2 to write down. Plus minus, right? Square root 1 minus x squared. But if we have this polar, this circle becomes what? Just a constant function. It's a constant function. Also, this graph is what? Almost like a linear graph. It's a linear graph. Okay. But in a polar coordinate, it becomes a constant function also. Okay, so once you change coordinate, some curve or function become easier. 降维了 and it just become constant function. Okay. So sometimes polar coordinate is useful, sometimes rectangular coordinate is useful. Okay, so in this case here, polar do a better job. Okay, so since you have seen this, okay, I want you to work hands-on now. So try and plot the following polar equation. So plot r equals to 2 cos t. So I suggest some angle for you to plot. So try and plot, try and compute what is this. For 0, power 6, power 4, power 3. Wait, so let's draw at least. Power 6, power 4, power 3, power 2, 2 power 3, 3 power 4, 5 power 6. Okay, try and compute these and then try and plot this um, polar curve here. Okay, try and compute all these and then plot it out. That's what I plot. Okay, this one is also another very important example in our class. Yeah, I give you 3 minutes. I think there's quite a few calculations to do here. Try to build intuition between the constant that we multiply to these polar curve. Okay, anyone try and plot out any nice picture? See. Not bad, not bad. Okay, so if you got these points out, let me see. These points actually quite symmetric, right? So if you plot them out, they are negative of each other starting from where? Starting from pi over 2. Okay, they are quite symmetric. So how do you plot these point out? Let's do it. So the first point you get 0, 2. Hey, sorry. Let's see how to see these quickly. Right, you get 0, 2. Or 2, 0 actually. We put r first, right? 2, 0. So radius is r, angle is 0. So radius is r, angle is 0. Okay, here. And then the next one we have square root 3 pi over 6. So you go up in angle, but you decrease in radius. You go up in angle, you decrease in radius. So decrease a bit. So square root 3, and then you go up pi over 6. And then you keep going up, pi over 4. And then your radius decrease some more. So you go up some more, and then your radius decrease some more. And similarly, you keep doing it. Next one. So you get radius 1, but angle become pi over 3. Okay. What happened at pi over 2? So, very important point to not in polar coordinate is this 4 important angle here, which is 0, pi over 2, pi, and 3 pi over 2. Okay, when you are at the angle of pi over 2, where are you? Actually, you are on this y-axis here. Okay, but the radius is 0. Okay, but the radius is 0. Okay, so you go back to the origin. So meaning what? Your radius is 0. No matter what angle you put, it's still the, because your radius is already 0. So no matter what angle you put, it's just the origin. And then so you can see the symmetry here, right? You can do the negative of all these points here. And if you plot it properly, it is a nice circle actually. But here is not nice. I'll make it nicer. Okay. Can you prove it is a circle or not? Can you prove it? Can you prove that it satisfies some circle equation? Ajay Tongse can. How do you do it? You learn it. That's most. I mean, so far, how we define circle, right? Satisfy some x squared plus y squared equals to r squared, right? Possibly you can change the center, okay? So how is it that x squared y squared equals to 1 here? I mean, equals to some radius squared. Multiply by r. Okay, so why do you want to do that? So, I mean, you need to remember one thing. Not that, how we go from xy to r theta. There's a formula, right? Gave by Yu Huang. So we have x equals to r cos theta and y equals to r sine theta. Okay, so you have to remember this. This is how you go back and forth between xy and r theta. But in this case here, we only know this function using r and theta. How do you turn into xy variable? So you can try and play some algebra here. Okay, so some algebra you can play here as well. Maybe you can multiply r to your function. Why do I do this? Because I need to create my x first or create my y first. Okay, but you can see that if I multiply an r to this equation here, I can substitute the x in. Okay, so I can express my s in terms of r now. Okay, is this useful or not? Is this already useful? Already useful. Why? And then r square is 1. At the same time, we also know that these point x squared plus y squared have to satisfy r squared. Okay, so we had x squared plus y squared equals to 2x. But it's not quite a circle equation, right? So how to make it a circle equation? You completing the square. Okay, so you completing the square. Do you guys know what completing square means or not? So you make a square out of it. So if you make a square out of it, what's the square you make? We make x minus 1 square plus y square equals to 1. 1 is 1 square. So what does it mean here? So this equation tells you what? Tells you some information about your circle, right? Where is it centered at? 1, 0. So actually what you draw is a perfect circle. center at 1, 0 with radius 1. Okay, so that's why this circle gets shifted from the origin. Okay or not? Does it make sense? Okay. Good. Okay, last thing, we will take a break after I introduce this word here. So, in general, in general, we will define a graph for Limassol. Okay, Limassol. Okay, Limassol is a French pronunciation. That's why this is a French word. So this is a French word for snail. Okay. A type of graph for Limassol for the following Polacca. So what kind of Limassol is this? So this Limassol is R equals to A plus minus B cos theta, and then R equals to A plus minus B sine theta. So I only give you see one variant of it. The variant I gave you to see is the first one, where A is 0 and then B is 2. Okay. So in general, what this picture looks like. So let me show you. If you change the parameter here, okay. So if you shift your cos theta, your circle is not quite a circle. Get flattened one side. You see, if you reduce this 1.3, this circle here somehow get pinched. And if you do it more, pinch more. Okay, and then you do it more, it spiral inside instead. Hey, pinch until it spiral inside again. Okay, and then cos theta is the one that we saw. So in general, they think that this looks like the snail. Okay, hopefully you think the same. When A equals to B, there's another name. They call it hardure. It looks like a heart. So this is the general picture you can get out if you play around with these two parameters here, A and B. So far, any question? Quite important, this shape here is quite important. Okay. So let's take a break until 11:02. Yeah, that's it. 在那怎么回来啊？你看资料，不能讲，现在要懂材料，只剩下一个理解，已经都，他天天都出，还没有立冬都没有到，对，有些点，你还没有立冬吗？我说你有这个是被春天了。要去玩 Steve， 所以没有啊，你是说他的 message 啊？not 他 IG 啊。任性，真任性。我爱你，不要生人。没有，就是来。匿名的好友啊，匿名的好友，好像匿名的，那就是很快。非常一样，跟杨丞琳讲一个，我跟你讲，是你看到这个他跟你讲吗？没有，看到了，讲多少？讲消化了啊，这个可能，因为你太任性了嘞。你要任性，史密德我要走，你不要聊课。
Simply.
Hello. I'll call name and then you tell me whether you have put down your assignment 1 and 2 feedback with your name submitted again or not. You still remember? Because your assignment don't have your name and student ID. So I want you to put down your name and student ID on the feedback file, the one that I marked. You put it, write down your name again, submit into the new link. Okay? Then submit to the new link. Don't submit to the old link. Don't, don't mess up with the previous submission. Let me show you first. So if you go to the calculus webpage, you should have assignment 1. Let's submit to this new link here. Check your feedback file and then put your name and student ID, submit here. And then there's another one for assignment 2. Okay. So for assignment 3, make sure you write down your name and student ID. So once I called your name, and then you tell me whether you have done it or not. Fan Yu, 来写啦，OK，好，可以，没问题。本来就写 is okay. Okay, I'm referring to those who didn't write down their name and student ID. 天童呢 have you rewrite your name and student ID? File name is not enough. You need to write on the actual paper. Okay, because when they do the checking, they just read the paper. Okay, so download the feedback file and then write the name and student ID and then submit to the new link. New link. You do it now? Do it now? Okay, thank you. 小鹏呢 Do it now. Okay. 金盛 Okay, good. Trade you submit already for both. Okay, thank you. 子莹呢加两个。OK. 炳雄呢这个没有写。OK，记得写啊。恩慈两个都有。OK。玉峰有没有写啊？OK。Isaac OK。加两。春夏两个都有写啊。玉良不送。威胁写了，本来就写还是加了？本来就有。OK，good。凯伦本来就有，Thank you。一翔还没有，OK。现在做还是现在？OK。伟权现在交了。安波做了吗？没有，现在做还是回去交还是现在做？啊，现在 OK，谢谢。小莹有吗？现在在做这，OK，两份啊。小杨呢两个都交了，谢谢。一瓶现在做好，红杰没有在，苍蝇没有在，今年呀，今天开始做3分3了吗？开始做啊。OK，有问题下个星期要问了，下个开始。All right. Let's continue. So let's practice to draw these snail limazone. And let's practice to draw the snail. So let's teach the technique to draw this snail. Right. So for example, let's sketch the following snail. Or actually cartwheel 了。你们喜欢什么？哎，sorry，你们喜欢爱心对不对？我们来画爱心今天啊。一两位的爱心都没有来上课了是吗？OK。R equals to 1 plus sine t. Okay, let's draw this. So how should we draw this? 哈，这个 polar curve 它疯掉了。Okay, so how to plot this? So let's plot the r theta plane first. Okay, let's start from r theta plane. Because we don't know how to make polar curve, but we can make it into xy plane first. Okay, meaning we treat r and theta as a Cartesian coordinate. Okay, if we treat it in this way, do you know how to plot 1 plus sine t? Okay, so the usual Cartesian way. Okay, so we have sine theta and then move up by 1. Okay, does it make sense? So let's draw it. So we have shifted out sine curve here. Okay, shifted out sine curve here. How to label? We have 1 and then 2 for the top amplitude. The lowest one is 0. And then for sine curve, really there are 4 important angles, right? You know the 4 important angles. So you have pi over 2, pi, and then 3 pi over 2, and then 2 pi. Obviously, you have 0. Okay. Do you know that these points will characterize this sine curve here? These are the important angle that you need to know. Okay. So I think if I draw it this way, then my graph a bit off. So let me. Sorry, too fast. So we need to pass through the pi first and then go down to 3. Okay, so how to make it into XY plane? So this is the technique here already. Okay, so here is the technique. So technique, how to go from R theta plane to XY plane. So let's go to the XY plane now. Okay, so let's draw it. So in XY plane, if you want to see it as polar coordinate, you also see it as 4 quadrant. Okay, so also there's 4 important angle here. It's the same angle. So we have, for example, 0, pi over 2, and then pi, and then 3 pi over 2, and then go back 2 pi. It's the same point. Right. So how do you transfer information here? Do you know how to transfer information here? If you want to transfer the whole curve, at least you need to know how to move one point first. Okay, so where's the first point? So the first point is radius 1, angle 0. So with radius 1, angle 0 on xy plane is what? It lives on the circle of radius 1 with angle 0. So it is the 1, 0 coordinate here. Okay, let's use other color. 1, 0 coordinate. Okay. Okay. But in the r theta plane, what happened? The radius increase. Okay, the radius increase of increase. Okay, increase. And then what else? Increase until where? Where does it increase until? Until 2. Okay, when you reach where? Pi over 2, the positive y-axis. So you keep increasing your radius until you reach the radius 2. When you touch pi over 2 angle. And then what happened after pi over 2? So basically, we also split into 4 sections here. So 1 section, 2 section, 3 section, and then 4 section here. Okay, let's look at these 4 sections. So we're done 1 section already. How about the second section? The radius decrease. Decrease until where? Until radius 1 again. Okay. But what's the angle now? The angle is pi. Okay, so where's your endpoint? Let's plot our endpoint here. So here is 1, and then sorry, what's this? What's this point here? This point should be -1, 0. Okay, so if you use your change of coordinate, do you know how to get these coordinate or not? So let me write it down for you. So you should use the formula x equals to r cos theta and y equals to r sine theta. Right. So at this last point here, the angle is pi. Cos pi is what? Cos pi is -1. So -1 times 1 is -1. All right. So you have your radius decreasing until you reach where? Until you reach this point. A bit ugly. Okay, never mind. Let's continue first. How about part 3? If you go around the circle, what else? What happened? The radius further decrease. Further decrease, decrease until where? Until 0. Okay, so your radius decrease until you want to reach 3 pi over 2, quickly decrease to 0. So when I talk about radius here, you should imagine a line like this. So you have a line like this. This is the radius that's increasing I'm talking about. this line is increasing. Okay, and then at the second part, it decreases. And then in the third part, it further decrease. Okay, further decrease until you met 0. Okay, until you met 0. Can see or not? Can see the radius increasing using this green line here. Okay, you increase, maybe a bit ugly, but you increase, and then decrease, and then decrease further until you get 0. How about next? Next, you increase again from 0 until you get radius 1. Okay? This is a distorted part. I draw not nice. But if you see your notes, it look like this. Okay? Yeah. 感觉更像屁股一点。星星的屁股。可能我们看一样的卡通呢。Yeah. Anyway. All right. Okay. Does it make sense? So we realize on this r theta plane to tell us how the radius grow. Okay, with respect to angle, and then you try and translate it back to xy plane. Okay. Xy plane is where we care. Xy plane is the only thing we care. Okay, we try to use polar coordinate to describe the rectangular group. So xy plane is really what we care. Okay, but the r theta plane will tell you how the radius grows. Does it make sense? Okay. Right. So next, we will learn roses. We'll learn roses. So let's define it. So the roses are the polar curve. So what are these polar curve? These are r equals to a cos n theta. Okay, so we, like what I told you, right? We make this time faster. But in this case, the shape change. Okay, in this case, the shape will change. Okay, so the claim here is, so the theorem here is the roses has n leaves if n is odd and 2n leaves if n is even. But I haven't defined for you what's this leaf yet. So I give you some example and then I'll leave it to you to define. So if you go down this shape here, so if you fix n equals to 2, you can see that there are like 4 petals here. Okay, they call it leaf. So there are 4. So n leaf. So 2n leaf if n is even. So this n is even. So there are 4 leaf. So there are 4 petals here. When n equals to 3, 3 is odd. So there's only 3 leaves. So exactly 3 leaves. Okay, when it's 4, there's 8. And when it's 5, there's only 5 leaves here. You see that they are quite symmetric. Quite symmetric. Okay. So similarly, we will learn how to graph this. You want to try out first? And then you try first, and then we discuss. Try graph this r equals to cos 2t. Use the r theta plane technique to do it. Try and graph this 4-leaf rose. I'll let you try. I give you 3 minutes. Try and graph this. Use the r theta technique that we had just now. Hey. 好，进来了。Okay. 对，
也是
重点是哦，还好意思请你。
还是谁？
做图的第一次
啊？
他在写11点有
哦，
地方成功
他还来没？
那讲话那讲
可以啦，最后什么都可以啦。
这个几个
隔壁什么 course？Okay, anyone have any try out? Do you get this R theta plane first or not? Is it the same? So if you speed up your 2 theta, right? So you will have a 4 period happening. So you have 2 period happening within 0 and 2 pi. Then if you trace it out, do you get this or not? You get it? Or at least some part is correct. So how to read it? You check from 0 to pi over 4 first, and then pi over 4 to pi over 2, and then and so on. So let's go through some of it. Okay, let's go through some of it. See if you are doing the right stuff. Okay, so where's the first point? Starting point is very important. Where's the important point here? 1, 0. Okay, so you get the 1, 0 up here first. Hey, sorry, this is a 1, 0 in r theta. So don't confuse. This is a 1, 0 in r theta. So why is it in xy is still 1, 0? What do you need to apply? You need to apply the formula. What's the formula? To go from xy to r theta. You need to do r cos theta and r sine theta. So it turns out that they are the same coordinate. Okay, so you need to compute. It's not just bring the 1, 0 down here. No. Okay, because you compute that 1 cos 0 is 1, and then 1 sine 0 is 0. Okay, so don't simply just convert point like that. You will be wrong, very wrong. Okay, so if you check the region from 0 to pi over 4, what happened? The radius decrease all the way to 0. Okay, so when you get closer to pi over 4, your radius get to 0. So you get to the origin. And then next part, you go from pi over 4 to pi over 2. But what happens here? You can see that the radius is growing. But what happened? It grows in the negative direction because your radius is negative now. Okay, so what happened? So let's check. So where's the pi over 4 and pi over 2 region? It's this part. Okay, still in the first quadrant. But your radius is negative. So you need to take the line, go through the origin, and then take the opposite point with the same radius. So you go from 1, 0 to 0, 0, but you go the other way, go to the third quadrant here. Okay. Does it make sense? Question? Any question? So this is very important when you take negative radius. Okay, so you plot out the positive radius first, and then you take the opposite point on the line that pass through the origin. Okay, remember how we discussed the point r theta and negative r theta just now? Okay, so you take the opposite one. Okay, so it falls inside this third region here. Okay, question? Any question? This is very important. This is the technical part already. Okay, this is technical part of this plotting. Then what else? When you go to pi over 2 and 3 pi over 4, it's still negative, okay, still negative, but the radius is decreasing. So if it is positive, supposedly it lives in the second quadrant here. But what happened? You take the negative counterpart. So it dropped to the fourth quadrant here. Okay, it go to the negative counterpart. So it go to the fourth quadrant here. And then you can see that the radius is really decreasing until you get 0. So 1 here, 2 here, and then 3 here. Okay, how about 4? 4 is good already. We are following the positive trend. Okay, so this fall into the right quadrant, which is the right quadrant. This is the second quadrant here. So going to from 3 pi over 4 to pi. Okay, and then you basically start the same story here. Okay. Any question? Okay, so the technical part here is the negative part. How do you deal with the negative radius? Okay, if you draw that wrong, maybe you have a wrong curve. Or the orientation is wrong. Does it make sense? Question? No? Okay. Actually, previous year, some students proved this statement here. Okay, actually, this statement is worth to prove. You can prove this. Or you can prove this for your girlfriend or boyfriend. I'm not sure they appreciate or not. Okay, yeah. Try and prove this. Okay, yeah. If you want to do it in your project, it's provable, not hard. Okay, it's okay. Right, sure. There are a few more exercises you can do. I don't have answer to this. Hey, do you guys have this solution? Oh, this one we did it already. And then this one, maybe we can try it out. Okay, I think I will add this solution in. You guys have this question on your pre-note? Or you guys don't follow? Maybe I think I will add this in then. I will add this in. The first one we already did it already, right? We did it. We put it into Cartesian already. But the second one, we haven't quite done it. But I might not miss it. So I think I make a mark here. I go back and try and do it, and then we can compare. All right. Right. Okay, so there are some symmetry that you can see. Maybe you can go back and try and read it. I don't want to discuss now. Okay. Cool. So, before we go into this, I think we need to at least do one more thing first. So let's do one more thing. How about dy dx on this polar curve? So let's define what's the tangent line. Okay. Tangent line to a polar curve. So last time we found a tangent line on a parametric curve, right? Where we can do the chain rule. What happened if we substitute y and x using r and theta? So what's the new formula now? Okay, so what's the new formula for the gradient in particular? Because really we only care about gradient. Line of equation, you just substitute the right point and then you can get a line equation. But what's the gradient here? So the main key point here is the gradient in terms of r and theta. I can show you it now first. It looked a bit complicated. Okay, a bit complicated. So it look like this. Okay, it look a bit complicated. It look a bit complicated, but the derivation is easy. Okay, so what's the derivation here? So let's write down first. So I mean, so from previous computation, right? previous definition, we know that we can use chain rule to write y in terms of theta and then differentiate x with respect to theta. But do we have this info or not? Do we have this info? Do you have this info? We should have, right? We know how to express y in terms of theta and x in terms of theta. What do we know? This is the very important two equation that you need to remember in this polar coordinate chapter, which is y equals to r sine theta and x equals to r cos. Okay, so this tells you that how x and y behave, okay, with theta. So how is it behaving here? But we know that the r is also in terms of theta, right? Based on my polar curve here. Okay, we know how these r responds to theta. Okay, so meaning what? My y and x is everything in theta now. Everything in theta. Okay, because r is also a function of theta. Okay, everything is in theta. Good. So how to differentiate in this case? Let me write down first. How to differentiate? Differentiate r sine theta over theta and differentiate r cos theta with over theta. So r also in terms of theta, meaning what? You need to differentiate product of function. Or you need to do product rule. So what's the product rule here? dr d theta sine theta plus r cos theta, okay, over r dr d theta cos theta minus r sine theta. So actually what happens to these terms are these terms actually come from product rule. That's all. Okay. So what is the r here? This r is the polar curve, f theta. Okay, if you like. Okay, so it's the f theta. So I mean, to be precise, maybe we want to put here f theta here. Okay, because our radius is really so that it makes sense to differentiate ours. Right? Okay. Right. I think it's time to let you see something. Okay, let you see something. Oh, let you see this thing. Okay. Wait, let me get my stuff out. What time is it? Okay, good. Right. So let you see this thing here. So far, actually what we have learned, let's look at a tree description of dy dx on the unit circle. OK， so 从小到现在啊，你现在看到3个 description。So what's the description I'm trying to talk about here? Unit circle, center at origin. So first, what we learn is, you learn is x squared plus y squared equals to 1. Second, previous lecture, we learned parametric curve. So how to use parametric curve to describe it? We use x equals to cos t, y equals to sine t. But exactly, this is how we go from polar coordinate, from regular coordinate to polar coordinate. Right? Okay. And the third way we describe it is using polar curve. How to describe polar curve? Describe the unit circle with polar curve. Is the constant function. I've read this one. Okay. So in all these ways, we have dy dx in different form. So first of all, if you want to differentiate this, what did I told you? We need to first split it into two parts. Okay. Top and bottom hemisphere. So we get what? 1 minus x squared. Then you can do dy dx on both sides, on both equation here. So if you compute dy dx, can you quickly compute in your mind? What do you get? You should get, I think, minus plus of x over square root 1 minus x squared. Try and compute in your mind. How to differentiate a square root? Okay. Do you get a chain rule or not? Do you get an extra sign? Okay. So if you put all these out, this is what you get. But actually, you can simplify further, right? Because we know what term is this. Okay, what is this? This is just y. Okay, this is just y. So how do we play around with this? Yeah, I think we should get minus plus x over y here. Okay, so why do I put a minus plus here? Because what? I'm referring to two equations here. So in picture, what does it mean? So let me draw the picture up. So basically, I split this circle into top part and bottom part. And then I do dy dx on these two parts here. Okay, so I do on these two parts. Okay, so the first answer will be given to the dy dx on the top hemisphere, and the second answer will be given to the dy dx on the bottom hemisphere. Semicircle, sorry. Not sphere. Okay, semicircle. But parametric curve tells you what? Dy ds equals to what? So maybe use another color. Use the chain rule to compute it. Or use the chain rule what? dy over dt over dx over dt. But in this case here, what do you get? You should get cos t over negative sine t here. But what is this? This is just negative cotangent t. Are they the same? The question is, are they the same or not? Hey, you use one way to compute x over y. You use one way to compute cotangent t. Are they the same? Why are they the same? Why are they the same? Why are they the same? One is trigo, one is xy. Same, eh? Why same? Equal to what? Cos t over sine t. But we have the description of xy in terms of sine t and cos t. Okay, so it's what? It's actually equal to negative x over y also. But note here, there's a very nice thing about this calculation here. There's no plus or minus. Meaning what? We compute all the tangent line at once. 一次罢了，我不用分开 differentiate. You understand? So meaning what? If you go around here, okay, they have the same sign. But if you go to bottom, this t will help you bring out the negative sign. Can you imagine? So when your t is on the above semicircle, it follow the formula. But if you check the dy dx on the bottom circle, this t, you should imagine the trigo function will give you a negative sign. And then this will help you to compensate this negative sign to get the positive. 算一次就好了 parametric curve. If you compute the usual way, 你要分段来算。Does it make sense? 这样的话，我们就会觉得这个比较好算。我算一次就好了，我算一次，上下的点我都给我算出来。Okay, but if you use the traditional way, 你要分段来算，分两半至少。But we still have the third way. Wow, what's this third way here? This is a constant function. We have this formula here. Is your r is constant what do you left with? 看得到吗？你 left with 什么东西？这边 ask theta。left with 什么东西？ If your f theta is 1, you also left with negative cos theta over negative sin theta. Formula 直接跑出来了。OK 吗？明白吗？ So let me write here again. So if, okay, use different color. If f theta equals to 1, okay, then the first term will disappear. And then what you left with is what? Cos theta over negative sin theta. It's the same answer. Any question so far? Okay, so make sure you see that these are all different calculation to the same thing. Yeah. 一个不是这个 OK
在某一个点上面会有两种点，就是一个正面。
You mean so? I mean the ambiguity you want to point out maybe is these two lines, is it? This is the point where they meet, where these two functions. 是吗？
Square root of 1 minus x squared, it must be positive, right?
So
X over the epsilon of
x over epsilon.
epsilon of y.
Oh. I get what you mean. Wait. What? Oh, you mean the technical part there? There. Think you need it. I think you need it. I think you need it. I think you need it. Yeah. To be precise, I think you need it. Right now, let me think. 啊？这是什么？我想一下。阿明啊？什么？啊？所以呢？OK。啊？什么？什么？对，我就要 consider two case，对，我就认真算出来就可以了。So if I seriously compute these two things, what do we get? I think first one we should get negative square root of x squared. And then the other thing we should get another one we should get x over square root 1 minus x. Agree? Okay, and then if I want to substitute back, one case we should get x over y. The other case we should get minus x over y. Let me think. Yeah. Okay. Then what? Then I don't need this, I guess. Yeah, I don't need this. I shouldn't have that. Because if I don't have that, if I consider this case, it's true, negative x over y. But if I consider this case here, since there is a plus there, but my y is a negative, so it should bring out this negative. So it shouldn't have an absolute. Yeah, shouldn't have an absolute. Yeah. To consider whether we want to put an absolute there or not, you just simply write out the both cases and then see how you combine these two cases. Because this y here will carry an extra negative. You get what I mean? So okay, how to read? Okay, so back out a bit, So how to read this? Formula here? Okay, so this formula here says if you follow the first one, you'll get the first answer. If you follow the second one, you'll get the second answer. But the second answer here require a negative, right? So so yeah. So if you want to, am I correct? So if I follow the negative, so am I saying that this is just like this? Huh? Yeah, 这样 yeah. Yeah, I think in both cases the same. Okay, thank you. Okay. But it turns out both answers. Yeah, correct. Yes. Because both answer computed the same. Right. Okay, any other question? Okay. Okay, so okay. But actually, later in future, we will learn another way to differentiate this kind of thing. We will use implicit differentiation. Okay, when we do partial derivative, where we use implicit differentiation. Right. Yeah. So what's next? Let me see what else we are having. Okay, so basically there's another exercise for polar equation, finding slope, finding tangent, horizontal line. So it's the same as XY coordinate. So I just pass. So you can do it as your homework. I provide the solution. I mean, this is the question I meant. Okay, so you try and do it yourself. So basically it's the same. Find the slope of a tangent line, just that it becomes a polar equation here. So you need to use the polar formula. Okay, and then you need to determine the tangent line, horizontal tangent line, and vertical tangent line. Is the same story, but you compute your dy d theta, dx d theta now. And then with this tangent line, you should plot out again your polar curve. Okay, it's the same story. Okay, same story with different formula. So I don't want to go through all these calculations. It's the same. Yeah, no? Yeah. So similarly, you use all these tangent line to plot out your curve. Okay, so next thing is this. This is a general polar curve here, maybe worth to look a bit here. So the easiest one I show you is the constant function radius. So it's a circle. And then if you try and put some sine theta here, you get another circle, but a different origin. So I show you the cos theta one. Okay, if you put sine theta, it shifted to y-axis. And if you consider this r equals to a theta, you get a spiral. So there's one very interesting spiral if you want to look at. It is related to the golden ratio. Okay, if it's related to the golden ratio. Okay. It's spiral with a golden ratio. And limesone is the one that we mentioned just now. So this limesone with an inner loop whenever a is less than b. And when a is greater than b, you have more convex stuff. And so you get closer and closer to a circle. And then we have roses. Okay, if you change the parameter of your theta, okay, you have the roses. And then the last one is lemniscate. So this is a figure 8 shape. Figure 8 is just mean the 8，像8的这个数字。OK， 8啊，什么？有笑点？ Yeah. So you can try and use this polar curve to describe the movement of your sun, right? You like. Okay, maybe you can change a bit, see. So this lemon scale actually come from this roses. Can you see it? Square of your roses. So after you square, the leaf disappear. Is it? Yeah, disappear. Because if you have n equals to 2, right, you're supposed to have 4 leaf. But after you square, it disappears. Okay, it reduces to 2. Okay. We still have 5 minutes. Let's go through what we have. See, is it worth to go through together? I think this is worth to go through together. Maybe we can go through next time. And what else worth to go through? So this one is a pizza. So how do you compute area of a pizza? Okay, if it's a circle pizza, it's easy to compute. But how about it's a regular pizza? Irregular pizza. Okay, can you still compute or not? Same story, you see? Is it the same story or not? You start from you know how to compute for a straight curve, and then you try to wiggle this curve. Then can you still compute the area? But if you have a wiggling curve, then you need to use integration again. Because why? We need to use straight curve to approximate the wiggling. Again, then we make the straight curve really small, and small. Take a minute. And so it's the integral. Okay, we can go through next time, but let's go through what we have first. Right, we go through these basically almost. Hey, your assignment not done. Not it's next week, right? Okay, I still have time. Okay, and basically this is almost the last thing already. So the last question is about area, right? So these you can look at it first, if you like. Not hard to follow. Maybe I can mention again next time. And then the last thing is about the again, arc length. You can still compute arc length. Okay, in the r theta coordinate. Okay, the derivative actually is not hard. Okay, you can see why is it so complicated. You can use the change of variable here. And then basically done with this chapter. Okay, hopefully we can finish it next week. And then after this, we will go into partial derivative. So partial derivative meaning you are not doing single derivative anymore. You need to do in different direction. Okay, maybe you do in x direction, y direction, z direction. Okay, so in that case, we'll look at a function again living in R3 at most R3 because that's the place we can throw it up. Yeah. Basically, it's R3 to R, but if you graph it out, it is in R3. R3 to R. So every point you have a height. At every point you have a height. 就像山，你想看如果喜马拉雅山不是被你压低，可能这个喜马拉雅山可以覆盖它国家是什么？不丹。Around there, around the region there. Maybe if you touch the Himalaya mountain, okay, maybe all the soil can cover all the country beside it. So what? So meaning this how you imagine a mountain? You can imagine the mountain as a piece of cloth, and then you attach different height. Okay, so this is basically the idea of that chapter. Once you attach different height, then we can see how the slope go in different direction. 对吗？你爬过山吗？你们有没有爬过山？有爬过吗？没有爬去爬，你来这边就有的爬了。你会发现呢，不同的路就不一样的爬，就是比较容易爬，有些路有些路比较陡，有些路就没有那么陡，就比较轻松。所以 if you look at a different surface, in different the slope will be different. So this is what we will compute next chapter. Okay, so 现在我们看到很多数学so try and think about a topic that you can do in your project one. And think about it. Okay, see you next week.
就加过分的那个版本，我再想一下。